All right, so in this lesson, we're going to learn how to multiply exponential expressions that have the same base. All right, and this is something called the product property. Now, our product property says that when you multiply powers with the same base, then you can add the exponents, right? So 4 to the 5th power times 4 to the 2nd power. Well, I know 4 to the 5th power is the same as 4 times 4 times 4 times 4 times 4, right? 5 times. All right. And I know 4 to the 2nd power, all right, 4 to the 2nd power is 4 times 4. All right. Now, if you're multiplying these together, how many total 4s do you have that are being multiplied? 1, 2, 3, 4, 5, 6, 7. All right. And that gets you, that's the same as saying that this is 4 to the 7th power. All right, because remember, if we're just multiplying the same number over and over again, you can use an exponent to rewrite it. All right. Now, essentially what we did is we just added the exponents, right? If this one had an exponent of 5, this one had an exponent of 2, you just want to add the exponents, right? This here's an addition, right? It's not a division. But yeah, we can do this anytime we see the exact same base and they're being multiplied, right? So we're going to do some more examples. All right, so this is the exact idea that I was highlighting before, right? So if I have 3 to the 4th times 3 to the 2nd times 3 to the 3rd, well, I know 3 to the 4th is the same as 3 times 3 times 3 times 3, right? 4 times. I know 3 to the 2nd is 3 times 3, and then I know 3 to the 3rd is 3 times 3 times 3. All right, so if you count all of these 3's, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 3's, right? So this is the same as saying 3 to the 9th power. All right, but you don't have to write it out every single time. As long as you see that they have the same base, our base is 3 each and every single time, and they're being multiplied, so you add the exponents, and then that's how you can also get this 9, right? 4 plus 2 plus 3 is 9. All right? All right, now the exact same thing works if I have negative or rational exponents, right? So my negative exponents, as long as, again, they're being multiplied, then you can add the exponents, right? So 11 to the negative 3 times 11 to the 4 times 11 to the negative 5, that's going to get you 11 to the negative 3 plus 4 plus negative 5. And then when you add all of those together, right, go from left to right, you get 11 to the negative 4. But to simplify your answer fully, right, we had said that we don't want negatives in the exponent, right, if the answer is fully simplified. So this is going to be the same as 1 over 11 to the positive 4, right? So that negative exponent is going to move your answer to the bottom, right? So that's how we get this 1 over 11 to the positive 4, all right? Now with a rational exponent, so if I have 2 to the 1/5 times 2 to the 3/5, that's the same as, again, 2 to the 1/5 plus 3/5, right? You can add the exponent because they both have a base of 2. So then you get 2 to the 4/5, right? And then you can just leave it alone like that. Now, there's a way to rewrite this, but we'll get to that in a later section, right? So don't worry about the fractions for now. Just as long as you combine everything that can be combined, you have your final answer. All right, so let's get started with some examples, right? On this page, there's some pretty simple examples. I'm going to start with number 1. I have a to the 2nd times a to the 3rd, right? If you don't see an operation between it, you assume it's a multiplication. All right, so I get a to the 2nd times a to the 3rd. Remember, a to the 2nd is the same as a times a. A to the 3rd is the same as a times a times a, right? So there are a total of 5 a's in this expression, right? So this is a to the 5th. All right, but you don't need to write it out every single time. What you can do instead is look at your exponents, right? I have a 2, I have a 3, they're being multiplied. So you can just add the exponents. It's a to the 2 plus 3, which is still a to the 5th. All right, so that still gets you your answer. All right, let's do the same thing with number 2. All right, so in number 2, I have a number in front, but don't worry about that number, right? If there's nothing that that number can multiply with, you just leave it alone. So I know my final answer is going to have a 3. All right, but once again, I can write out n 3 times, and I can write out n 5 times, and I can count, or you can just do n to the 3 plus 5, right, since they're being multiplied. And 3 plus 5 is going to get you 8. So my final answer is 3n to the 8th power. All right. Now, with this next one, right, notice that I have an 8 here, but that 8 can be multiplied with this 3, right? So I'm going to do 8 times 3, which is going to get me 24. All right. Now going on to the variables, right, I have a k to the third times a k to the 6. Now once again, when you're multiplying, you want to add the exponents. So this is going to become a k to the 3 plus 6. And in total, that's going to get you 24 k to the 9th as your final answer. All right, so hopefully you can see that they're not super difficult, right? These are some of the more basic examples, but nothing really it doesn't get too much more complicated than this. All right, so this next one, 8p to the 5th, 6p to the 4th, right? Again, if you don't see an operation in between, you assume it's a multiplication. All right, so I'm going to do my numbers with the numbers. So 8 times 6, that's going to get me 48. And then I'm going to do my variable with the variable. So I have a p to the 5th and a p to the 4th. They're being multiplied, so it's going to become a p to the 5 plus 4. And that's going to get you 48 p to the 9th, right? Add your exponents. All right. Now you can do the exact same thing if you have multiple factors, right, with the same base, right? I have an h to the 5th, h to the 2nd, and an h to the 10th, right? So it's going to become h to the 5 plus 2 plus 10. Right, so add all of these together. 5 plus 2 is 7, and 7 plus 10 is 17. So this is going to get you h to the 17th power. All right, now this next one, once again, I want to do my numbers with the numbers, the variables with the variables, right? So let's see what matches. I have a 9 as a number and a 6 as a number. Sorry, a negative 9. All right, so I'm going to do negative 9 times 6. That's going to get me a negative 54. All right, and then I have a q to the negative 8 and a q to the 11th. So it's going to become q to the negative 8 plus 11. Now, negative 8 plus 11 is going to get you a positive 3. So my answer is going to become a negative 54 q to the 3rd. All right, let's do some more. When you have multiple variables, like in this case in number 7, I have a y and a z, you can still do the same thing just as long as you match your variables with the correct variable. So if I have a y, the y is of course going to go with the y. The z has to go with the z. Right, so I'm going to have a y to the 3 plus 2, right, because we're multiplying here. And then I have a z to the 13 plus negative 6 is going to get you a minus 6, right? So let's go ahead and combine these. We get a y to the 5th, and then z to the 13 minus 6 is going to be a z to the 7th power. All right. And now with this next one, right, I have multiple m's here, right? So I have an m to the negative 6, n to the 3, and n to the negative 2. Right, so again, I want to match everything that matches. So m is going to match with n. Nothing goes with n, so I'm going to leave that alone. So I'm going to have an m to the negative 6 plus 3, and then times an n to the negative 2. Now, if you simplify this, negative 6 plus 3 is going to get you negative 3. So I get m to the negative 3 and an n to the negative 2. Keep in mind, we don't want a negative in our final answer, at least not in the exponent. Right, so I want to use my power property of negative exponents that we learned in the previous section to bring the exponent down, right, to make it positive. If I have a negative, I know that if I move it to the bottom, it turns that exponent positive. Same thing with this negative 2, right? If I bring it to the bottom, that's going to make it positive. So my final answer is going to be 1 over m to the 3 and n to the 2, right, both positive. Right, once you move its space, then it's positive. All right. And now, number 9 here, right, just like some examples that we did before, I want to do my numbers with the numbers. So 16 times negative 2, that's going to give me a negative 32. And then I have an r to the negative 7 times an r. That's going to be an r to the negative 7. And if you don't see an exponent, you assume it's a 1. So plus 1. All right? And that's going to get me a negative 32 r to the negative 6. All right? Now I want this negative exponent to be a positive. So to make it a positive, I would bring it to the bottom. Right? So my final answer is going to be negative 32 over r to the 6. All right? Some questions that may arise is, why didn't you move the 32 also? I didn't move the 32 because r is the only thing that has a negative 6 as the exponent, right? And I also kept the negative 32 on top, just because if you see a negative, doesn't always mean you're going to move it, right? You're only going to move it if the negative is in the exponent. So negative 32, your answer can be negative, you just can't have a negative in the exponent. So hopefully that distinction is clear. All right, so we got 3 more examples. This next one, once again, we're going to do the same thing. It might look a little different than some of the other ones, at least in terms of the way it's formatted. Like maybe you don't see the parentheses, but if you don't see the parentheses and you just see the multiplication symbol between them, that's fine. You still just multiply. So I would still, once again, I would just go number by number and variable by variable, right? So I see my 2 numbers here are negative 6 and 7. I would just multiply them, right? So negative 6 times 7 is going to get me a negative 42. All right, and then I would go variable by variable, right? So j goes with j. And once again, if you don't see an exponent, you assume it's 1, right? So this is j to the negative 3 times j to the positive 1. So a negative 3 plus 1 goes in that exponent. And then I have a k and a k to the 5th, right? Once again, if you don't see an exponent, assume it's 1. So it's going to become k to the 1 plus 5. All right, and then I would just go ahead and simplify this. Negative 42, you still can't do anything with that, right? But then j would become j to the negative 2, right? Negative 3 plus 1 is going to get you a negative 2. And then k to the 1 plus 5 is going to get you a k to the 6. Now, once again, we don't want negatives in our exponents, right? So I want to go ahead and change that to a positive by moving it to the bottom. So I'm going to take this entire expression right here, this j to the negative 2, and I'm going to move it down to the bottom and make that exponent positive, right? So negative 42 is going to stay above. K to the 6 is also going to stay above. Over j to the 2 is going to go on the bottom, but it's going to become positive. All right, so we get that as our final answer. All right, now we can keep going with the next one, right? We just have an extra variable, right? But it's the exact same process. So this is going to become negative 2 times 3, right? That's going to get me a negative 6. All right, u times u to the 2nd. Once again, you don't see an exponent, assume it's 1. So it's going to become u to the 1 plus 2. All right, and then I have a v and a v to the negative 2. Once again, don't see an exponent, assume it's 1. It's going to become v to the negative 1 plus 2. And then I have a w to the negative 1 and a w to the 1, right? Once again, write the 1 if you don't see an exponent. And it's going to become w to the negative 1 plus 1. So let's go ahead and simplify everything that can be simplified. All right, so it's going to be a negative 6. U to the 1 plus 2, that's going to get you a u to the 3rd. All right, and then v to the negative 1 plus 2, that's going to give me a v to the 1st, right? And then a w to the negative 1 plus 1, that's going to get me a w to the 0. All right, so, oh, I made a mistake. All right, sorry. So it's going to become v to the, sorry, this is going to become v to the 1 plus negative 2. All right, plus negative 2 is going to get you a negative 1. Yeah, sorry about that. But let's just keep going. So this is going to get me a negative 6. U to the 3rd, that stays the same. There's nothing more that you could do to that. And then a v to the negative 1, right? If you have a negative in the exponent, you're going to move that to the bottom, right? To the bottom of this expression. So it's going to become over v to the positive 1. And then w to the 0, anything to the 0 power, hopefully you remember this from last time also, is 1. So I'm going to get rid of that and replace it with a 1. Right, now if you're multiplying anything by 1, it just stays the same, right? It doesn't change the value. So my final answer for this one is going to be negative 6, u to the 3rd over v. You could say v to the first power, right? But if it's to the first power, you don't need to write the exponent. So that's your final answer. All right. And now just one more. Same idea, right? So I'm going to multiply all the numbers together, right? I have a 15 and a negative 8. I don't see a number in front of this group, so I'm just going to leave it alone. And then 15 times negative 8, you can do that off to the side if you need to. I'll do a 15 times 8. All right, that should get you 120. And because 8 is negative, it's going to be a negative 120. All right, and then move on to your variables. All right, so I have an f to the third, and an f to the negative 1. Again, if you don't see an exponent, assume it's 1. So it's going to be f to the 1 plus 3 minus 1. All right, now with g, I have a g to the second, g to the negative 3, and a g to the 6. So it's going to become a g to the 2 minus 3 plus 6. All right, and then we can simplify these. It's going to become negative 120. F to the 1 plus 3 is 4. 4 minus 1, it goes back to 3. Right, so f to the third. And then g to the 2 minus 3. 2 minus 3 is negative 1. And then negative 1 plus 6 is positive 5. All right, so then this becomes your final answer. All right, now that's as complicated as just the multiplying problems go. In the next 2 videos, we're going to talk about the other 2 rules of exponents, so power to a power and then the quotient property.